Aku mah minimal lah, ini ada. Aku mah
Good afternoon, dear participants. So let me all warmly welcome to the beginning of awareness session, Introduction to Condition Audits in Electrical Distribution Systems, which is organized by Electrical, Electronic and Telecommunication Engineering Sectional Committee. As some of you guys might already know, we are continuing a project which is Walkthrough Energy Audit for Apeksha Hospital. So in order to get the maximum contribution out of our precious undergraduates, we have specially organized online training session, which is Condition Audits of Electrical Distribution Systems. And today is the very first day, the beginning day of our journey. So without taking any further time, let me invite a special person to welcome you all for our session. He's a chartered electrical engineer as well as international professional engineer with enormous experience in this field of electrical engineering. He is Engineer Chamil Edirimuni. The time is yours, sir.
Thank you very much for that introduction. Actually, I would like to thank all of you who has arranged this session. I think this is the second one. So this will be a much elaborative one based on the energy audits, actually the condition auditing. So I must, on behalf of the electrical sectional committee of both Engineering Council and also IESL, I must welcome you all because we have likes of engineer Audit, apart from our resource person. He's a well experienced resource person, Engineer Veranga Dasanayaka, will be lighting on you the facts on engineering audits, conditioning audits. And Engineer Dr. Bonara, who is always with us and who is giving his expertise, knowledge on this field of concern. So Engineer Sapmal Valsundar is also one of the pioneers in handling this one. So I must also welcome you, even though you are coordinating this, and welcome all our undergraduates of universities. Before I will take 1 or 2 minutes to tell you some kind of background on this, because at the time 1 year back we decided to start this as a CSR project. And why only us? Why not we involved with the university? So this field, especially this energy conservation, if you take a look at before, because I had a one news item here, before it is been entered into your home or a kind of a manufacturing plant, at least 1/5 of energy being lost in the system itself. So Sri Lanka is a small system, but with less energy losses, but it has accumulated, I think. But then after it has arrived your home or whatsoever, now our targeting thing is our targeting location is Apeksha Hospital, which is meant for the cancer patients. So we thought that this is the best place that we can start this energy auditing. So we thought of inviting you all who are and all who want to conduct this energy audit with us. We will share the knowledge with you. We have enormous talent. I think you got many skills, and our resource persons and all has got the experience how to do it. The subject is, nevertheless, is a will be continuing forever, because energy saving, it will go into bits and bytes in many, many years to come. So this would be very much of a very important one to you, so that I think you will feel very maybe generous about that. Having taken part of you, that is up to you to continue this, and not limiting to these things. We are going to have many successful CSR, and also collaborating with you in the future also, because not only we are going to stop by these kinds of sessions, but we will like to know you better. Come and join with us, even in the ESL and whatsoever places, to do these things, because that will be of a carry a value to you in the future as well. I must tell you so. If you want to do a job, if you want to make a profession here, so I think we also can help you on that regard, giving so much support to you, and also acquiring your skills and knowledge and your enthusiasm for this kind of work. So without further ado, I will just pass over this to the coordinating team, which is who are doing a wonderful job. And thank you very much for inviting me to take a part of the welcoming speech. Thank you very much.
Thank you very much, Engineer Chamil Edrimuni. Let me introduce myself. I am Koshala Chandrasena, and I myself as an electrical engineer. So today I will be comparing this session for you guys. And right now we have come to our main session, what you have been waiting for, the condition audits of electrical distribution system. So it is a must for me to take few minutes and introduce our distinguished guest for you guys. He's an accomplished electrical engineer with a remarkable track record in the design, construction, supervision, and testing of electrical installations, as well as his expertise extends to the direct management of electricians, making him a valuable asset in this field. If I am talking about this person, he is acknowledged as a registered freelance consultant in the Ceylon Electricity Board, as well as he holds this precious title of Chartered Electrical Engineer, signifying his dedication to professional excellence in the field. As well as I mentioned, currently serving as a consultant engineer for several renewable energy firms, his influence also extends to the academia. He is a visiting lecturer at the Faculty of Engineering, University of Ruhuna, where he imparts knowledge on the electrical installations module to final year undergraduates. As well as I have mentioned, he has diverse roles in this field, and his involvement spans a multiple of projects, including multi-purpose development buildings, warehouse buildings, condition audits on electrical systems, waste to fuel initiatives, water supply projects, rooftop solar PV systems, and so much more. As well as he holds this esteemed title of corporate member of the Institution of Engineers Sri Lanka, as well as associate member of Sri Lanka Energy Managers Association. So I know you guys might be curious to meet our guest. So without taking any further time, let me introduce you to our resource person, Engineer Veranga Dasanayaka. So he will be concluding our main session, and before handing him over this session, I would like to remind our participants some small rules. We need your help and support to our engineer Viranga Dasanayake to continue our session successfully. So I would like to mention to all of you guys to mute your mics and turn your cameras off during the session unless you are asked to turn them on. And as well as if you have any questions to raise, we have a separate time for our Q&A session, so you can raise them there. So I know I spent quite a lot of time introducing our guest, so let me welcome him. Engineer Viranga Dasanayake, the session is yours.
Thank you, Engineer Kohila, for your tremendous introduction. I think you all can hear me, no?
Yes, sir, we can hear you.
Yes, thank you, Coach. First of all, I would like to thank Engineer Samila Girimuni, the former chairman of Electronic and Telecommunication Section Committee, as well as Engineer Navodana Pankangge, who was the vice chairman of the same committee, and for giving me this opportunity, and also Engineer Kapumal Vadisundara and Engineer Koshila for coordinating this session in a very short period. Let's start our session today. I have shared the presentation. I think you all can see now in your screen, no? Okay. So today our topic is introduction to condition audit in low voltage electrical distribution system. So first, our aim is first one is to understand the basics of low voltage electrical distribution system. Because before you are going to do a condition audit, you must understand the basics of low voltage electrical distribution system, because this is deal with when you are doing condition audit, you are dealing with this low voltage electrical distribution system. So before to introduction to condition audit, I will explain you the basics of low voltage electrical distribution system. After that, I will give you an introduction to condition audit. So here, this will be a little bit complex schematic diagram of electrical distribution system. I think you can see here there are several parts in this system. First one is you have a utility supply from a CB or LECO. Then you have a standby power supply system. So first, these two supplies will be given to automatic transfer switch, which we call as the ATS panel, or it may be a manual changeover switch to switch between main source and standby power supply system. So this is the main incoming point of this low voltage electrical distribution system. After that, it will go to your main switchboard of the system. Main switchboard distributes the power to all other sections in a building or a premises. So this is the main schematic of the electrical distribution system. So next I will explain you mainly the components of this system. So here in this schematic diagram, you can see there are three number of parallel transformers feeding this electrical distribution system. which we can call as a medium voltage system. Most probably, this kind of arrangement will be done by a utility supplier, but in some mega projects, this will be done by the premises owner technical team. So this one is little bit complex system when you are going to a medium voltage system rather than LV distribution system. Here, this is how medium voltage system components are installed in the system. First, you have transmission line which comes from power station or national grid. That transmission line feeds mainly a medium voltage panel in your premises. After that, the MV panel feeds to a transformer which converts to a 33 kV or 11 kV voltage into 400 volts, which we are using as our system, what we call as our frequency. Our frequency which we use in our houses or commercial buildings or the other buildings. So that is the usable voltage and the frequency. The main component is the conversion is doing is the transformer. So when we are looking at the major component from this MV panel to feed the transformer, you can use a medium voltage cable. The cables may be in a cable tray, or a cable ladder. So if you are going to visit the site, please inspect whether how these cables are installed, or in a cable tray, cable ladder, or a train, because it is very important the installation method. Because if you are install a cable underground in a cable train, the current carrying capacity of the cable may be reduced rather than if you are going to install it in a cable tray or cable ladder. So when you are installing a distribution system, it is required to calculate whether the used cables are adequate to carry the current in the system. So this is what we have to inspect in a medium voltage system. So next we will go for a standby power supply system, which is feed by a diesel, mostly feed by a diesel generator. So after the diesel generator, same as before in medium voltage system, the cable may be go through a cable tray, cable ladder, or an underground cable. Then it comes to a automatic transfer switch or manual changeover switch. I think if you have visited some larger scale buildings, you can see this kind of installation in buildings. Mainly, most of those buildings have a room called electrical room. If you visit this electrical room, you can see or identify these components clearly in this electrical room. Then, when we call a standby power supply system, you can see basically there are two types available. One is open type generator, another type of soundproof canopy type. In most of the sites, you have seen the generators with soundproof canopy, and there are also open type generator installations also, which are operating parallelly synchronized systems, mostly in a larger scale installation. When you are going for a low voltage system, this you can see the first point is automatic transfer switch for the manual changeover, which I have mentioned you earlier. There are two incoming supplies there. First one is with power or the main power source, and the other one is standby power system. The task of this automatic transfer switch is it can detect the availability of main power or the standby power. The priority is given for the main power supply, that means peak power. So this switch mainly focusing on the main power, and if main power in the main power failure, automatic transfer switch passes a signal to your generator to start the generator, because now main power source is not available. Then after generator gets started, then standby power coming to the automatic transfer switch. Once we detect that power is coming to the APH, then it automatically transfer load to the standby power side. This will happen mostly within 10 seconds of time. So the premises can Sapumal says that my sound is not clear. Is that so?
Engineer Veranga, this is now. Then actually your sound is low, clear.
That means something issue with my microphone, I think. What we can do?
Yes, maybe the sound is clear, but the sound is not much higher. Shall we remove the mic and talk directly to the computer?
Yes. Now is it okay?
Yeah, now bit better, no? Yeah.
Yeah, now it's okay.
I think now you can hear me, no? Clearly?
Yeah, yes, sir.
Okay, thank you very much. When the automatic transfer switch detects the power is available at the standby power supply side, it will feed the main distribution board of the LV system. Then at the LV distribution board feeds several flow distribution boards or sub-distribution boards in the system, which allocated in several zones of the building or the premises. Then finally, there are which we call as consumer units. That means, I think all of you may know, in your houses, there are small distribution boards available to distribute the circuit inside your house wiring. So that type of distribution board we call as consumer unit. That means the final circuit and the final electrical equipment all are connected to this kind of small consumer unit. That's how power is distributed among a low voltage electrical distribution system. So when you are going to do a audit in an electrical distribution system, you have to clearly identify what is the automatic transfer switch and what is the main distribution board and what are the flow distribution board and so what are the sub-distribution board, then what are the final distribution board, that means the consumer unit. When you identify these major components, you have to make a small sketch on the paper, the distribution arrangement. You can use this kind of simple block diagram to demonstrate that system. So then, after that distribution, you can use the single line as I told you previously. Then, from automatic transfer switch to main distribution board, the power can be transferred through a bus trunking system or an electrical cable. I think you all have know what are the bus bar trunking systems are. It's some components which are used to handle high current. As you know, now electrical cable cannot handle too much current. Therefore, we have to use multiple cables for a single phase. To avoid that, we can use bus bar trunking system. They can handle current like 6,300, sorry, 3,600, 10,000 like that. The bus trunking system can very high current and they are very what we call the very small. I think when we are using multiple cables, we have used a very wide cable trays or cable ladders, like a very wide cable management system. But when we are using bus trunking system, in very small space, we can accommodate it. So our transmission distribution can be done in a very small space. So mainly you may see these type of power distribution arrangement when you are going to a building. So you should identify how this power is distributed from cables or from a bus bar trunking system. Mostly after main distribution board, the power is distributed using a cable. To support those cables, you can use cable trays, cable ladder, or cable transmission. So finally, when this power comes to the final circuit, you may all have seen the cables are routed through conduit. So this is how the cables are managed throughout the building or a premises. The importance of identifying these kind of cable management systems is based on the cable management system, the current carrying capacity of the cable is varied. As an example, if you take 16 square millimeter copper cable, the current carrying capacity in a cable tray is higher than if this cable is enclosed in a cable trunking or a conduit. As example, if you say 16 square millimeter cable roughly can handle 60 ampere current. But if you are enclosed it in a cable trunking or conduit, this 60 ampere current may be reduced to 50 ampere or 40 ampere. So that's why it's very important to identify the methods of managing the cable. When you are doing condition audit in the system, you have to do you have to record the methods of cable installation. That's why I am explaining these things prior to giving an introduction to condition audit. So these are very important factors when you are inspect a low voltage system. This is some terminology which we use in electrical engineering. First one is MDB. So mainly when we are talking inside or when we are dealing with electrician or technical person, we always not explain the long term, like that main distribution board, flow distribution board, subdistribution, like that. Always we are not telling the long term. Instead that we are talking MDB, FDB, FDB, TU, TB, like that in short form. So when you are dealing with this technical person, you must know, if I say go to the FDB, so you have to know what is FDB. When we are asking you, first go to MDB and say what is the voltage there. So you must know what is the MDB and you have to find where it is installed. So that's why we are giving this terminology to you to understand the basic things we are talking with the technical people in the industry. So if you are, you can see several types of this distribution board. Some can be surface mounted or some can be flush mounted in the wall. And there are another type available, it's called as a freestanding. That means they are mounted on floor. So when you are doing this audit, you have to clearly record what are these distribution boards and how they are mounted, because sometimes some distribution boards are some very heavy distribution boards may be mounted on wall. So it cannot be withstand because of its weight. Maybe it can be collapsed in some time. So therefore you have to clearly know that kind of thing, whether this distribution board can be mounted on a wall or this should be it should be converted to a freestanding type. So these kind of things you have to examine very well when you are inspect our distribution system. If you see inside the power distribution board, you can see this kind of components are available inside this panel board. There are air circuit breakers, which we call as ACB. Then molded case circuit breakers, which are called as MCCB. Then miniature circuit breakers, MCB. Residual current circuit breakers, RCCB. Then changeover switches, isolators, indicator lamps, fuses, earth leakage relays, phase failure relays, power meters. It can be digital or analog, and surge arresters. Like that, there are so many components inside this kind of electrical panel board. Always we are using this kind of terminology to identify this kind of components: ACB, MCCB, MCB, RCB. Then earth leakage delay we can use ELR, phase failure delay we can use PSR. Like that, you have to familiar with these words. before you are going for a condition audit of the system or the dealing with electrical engineering. You must familiar with this terminology. That's why I am telling these things as an introduction. These are some pictorial views of the component which I have described previously. First one is the air circuit breaker, which can handle high current. That means about 1000 amperes. We have to use air circuit breakers. Sometimes these air circuit breakers can handle up to 6000 ampere level. The molded circuit breakers can be used up to 1500 amperes, from 100 ampere to 1500, like that. MCBs you can use only up to 50 ampere only. After 50 ampere, maximum is 50 ampere available at MCBs. After that, you must use molded circuit breakers. Then you may all have know this device, circular current circuit breaker, which we call as flip switch in your house. So next one is the changeover switch, which can be used instead of automatic transfer switch to transfer the main power to a standby power, or from standby power to main power. We can use the changeover switch. Next one is earth leakage relay, which detects the earth fault in the system and gives tripping signal to air circuit breaker or the molded phase circuit breaker. Then next one is the phase failure relay, which we call that PFR. It also sends a phase failure in the system, because in a three-phase system, all phases to be available healthy to operate three-phase load. If one phase is failed, the equipment may be damaged. Therefore, to avoid that damage, we use phase failure relays to detect a phase failure or an under voltage in the system and trip the main circuit breaker. Then digital power analyzers are used to analyze the power available in the system, and if you can read the voltage, the current level, or the voltage, or some analyzers like it to measure the harmonic levels, like that. The digital power analyzer can be used to measure or take the system parameter like voltage, current, and voltage. So next, you can see some voltmeters and ammeters also. Then surge protective devices, which are used to protect the system from lightning or hitting transient. So this is also very important device in a low voltage system. Then indicator lamp, which indicates the availability of power. So basically, you have to know this kind of major components in the electrical panel to examine the power distribution system. This is some example of power distribution system, which is denoted by a single line. Basically, electrical power system we are represent in a single line diagram. That means whether it is a three-phase or a single phase, we are showing only one line to denote the phase line. Here, neutral line is not showing, because always neutral in our electrical system, neutral is considered as a common conductor. Therefore, mainly we are switching or separating the phase conductors only. So the single line diagram denotes how the phases are separated into several feeders or several power distribution lines. So it is very important to understand single line diagram when you are preparing an electrical low voltage system, because all as-built drawing or design drawing of electrical system interpreting using this single line diagram. Here, main circuit breakers, ELR, surge protective devices, and main MCBs all are showing in this single line diagram, and where they are to be placed in the system is clearly indicated in this single line diagram. So next thing is, next very important thing is you have to learn how to read single line diagram. As I mentioned you earlier, there are another system called bus function system. Instead of cables, we can use this kind of system. There you have to see some bus bar material. That means in this system, you can use copper as a one conductor system. Or we can use aluminium as a conductor. Or there are another called copper contact aluminium. That means inside this bus function system, conductors are made of aluminium, but at the end, this aluminium conductor is converted to a copper contact using biometric reaction. There is a technique to convert this aluminium conductor into copper conductor at the edges of the bus function system. Because of most of circuit breakers, the contacts are tinplated copper. So if you are directly terminate a aluminium conductor to a circuit breaker, there can be a biometric reaction happen in the contact point. If that happens for a long time, the contact is not adequate to pass the current to the system. Therefore, the point of termination point can be heated because of this corrosion, and after a long time, because of the heat, fire hazard can be happen also. Therefore, when you are inspecting this low voltage system, you have to clearly see whether proper terminations are done. We cannot allow aluminium conductors to terminate directly to the circuit breakers without biometric plug or copper contact aluminium system. So therefore, another important point is we have to examine those things. So then this kind of bus function systems there are two types. One is internal earth and the other one is integral earth. That means some bus functions are available with 5 conductors. That means inside the bus function there are 5 conductors for 3 phases, neutral and earth. There are 5. Some bus function uses their housing as the earth. So inside the bus function there are only 3 conductors, so 4 conductors for 3 phases and neutral. The housing is used as the earth. That is called as integral earth. So when you are going to the site, you can see these 2 kinds of bus function systems. So you can you have to identify whether it is an internal earth or integral earth. To take power out from the bus function system, you are using tap-off unit. That means this tap-off unit, in some point, this units are tapping the conductors inside the bus function system and give you some termination point. That means if you want to take power out from this bus function system, you have to use tap-off unit to take power out from this bus function system. The current ratings of bus functions are available 800, 1000, 500, 200 MPa, etc. And also there are different types of IP ratings also available, IP64 and IP65. I think you all know what is IP64 and IP65. That means if I tell you that first IP rating is given for a, you can define for a electrical component to protect it from dust or the from liquid. The first number tells you to protect from what is the protection from dust, and the second number denotes its protection from liquid. There are numbering systems. So based on that, you can see these two types of bus tracking systems are available in the market, IP64 and IP65. When you are going for a power cable, there are several types of power cables are available in the market. First one is armored cable. Armored cables are basically used to distribute power underground or in open area, because these armored cables are equipped with steel wire armor around the conductor. So, sorry, here this one is an unarmored cable. Unarmored cable is there is no mechanical protection. There is so this is an armored cable. Very sorry. This first one is an unarmored cable. That means there is no any mechanical protection around this cable. Just there is an insulation around the conductor, and there is a PVC sheet surrounding all the conductor. So if you are indicating this kind of unarmored cable in a single line or a drawing, you have to use this type of notation. You can see the first one is 10 square millimeters. That means the cross-sectional area of a conductor inside this cable. Next, Cu means the copper. That means the conductor material. What is the conductor material? It can be, as I mentioned, it can be an aluminium cable. So, if it is aluminium cable, its Cu will be replaced by Al to denote as aluminium. So, mainly we have that two types of cables. First one is copper or aluminium. So, this is the conductor material. Then next, PVC. And PVC means the material around that conductor material. That means the insulation. To insulate this copper conductor or the aluminium conductor, you can use the PVC as the insulation material. There are another material called XLPE, which we can use instead of PVC. There are cables available in the market. Copper, XLPE, PVC also. So next one is the sheet material. That means around these all conductors there is another cover which we call as a sheet. This is also made of PVC material. Then after that, finally we have used 5C. 5C means 5 core. If your cable with 3 cores, you have to use here 3C. Like that, this is how you are interpreting a power cable in a drawing or a BOQ or a specification. So next type is armored cable, as I explained earlier. Inside this inner sheet, there is a steel wire armor to protect the inside conductor from mechanical damage. Basically, this kind of cables are used in heavy because the industry or the factory, where the cable can be damaged due to hitting power moving equipment or very heavy load. So the difference between these armored cables is when you are denoting after the insulation material, you are using notation SWA for steel wire, telling that steel wire armored cable. Here you can see there are 3 conductors inside this cable. So we are putting 3P after all this things. That means this armored cable is a 10 square millimeter size conductor which is made of copper material and insulated with PVC material and protected by steel wire armor and covered by a PVC sheet. That is the meaning of this notation, and it is a 3/4 cable. Like that again you can see fire cable called fire resistant cable in the electrical system. That means most of emergency circuits. That means in staircases, emergency lights, or in corridors there may be emergency lights, or if you are going for a hospital, the theater room, it should be always powered in an emergency situation also. That means in a fire condition also, there are several places to be operated inside the building. So if we are doing a wiring, this kind of special location where it should be operated in an emergency cases also, we have to use fire resistant cables. That means in case of fire also, the power we can guarantee our electrical system is working during a fire situation also if we are using fire resistant cables. So the difference between these fire resistant cables rather than normal power cables, after the conductor material, that is after the conductor, there is a fire barrier. Most probably this will be a MGT, that means mica glass tape. This material is a very fire resistant material. If you are putting this mica glass tape on a flame, this will not burn. So this material is used to protect this cable from a fire situation. So after again, this mica glass tape, as the previous cable, there are insulation material and sheet material, and there are showing the number of holes. Like that, you have to use different kind of these cables in your system. These are some cable management systems. I think I already explained to you this cable management system type because this is very important. When you are putting cables in this cable management system, the current carriage capacity will be different for the same cable if you are using different kind of management system. For same cross-sectional type cable, if you are putting in a cable tray, in a cable ladder, in a cable trunking, the current capacity is weight. Therefore, you have to clearly see where these cables are installed. So again, in the Audit system, there is important one is uninterruptible power supply system. Basically, in NOC room, that means network operation center in a building or another theater room in the hospital, like that, the power cannot be interrupted during the operation. So we use uninterruptible power supply system to provide them uninterruptible power supply. So we are using mainly 3 types of UPSs. First one is direct online or line interactive. There may be single phase or 3-phase distribution, single phase or 3-phase UPSs. Or we can use a single UPS or a parallel system. That means if we cannot cater power from a single UPS, we have to parallel 2 UPSs and we have to keep the power. So when you are going for to extend an electrical distribution system, you have to clearly explaining these kind of things. What are the components available in this system, whether the UPS are installed in this system. And also, backup time is very important because with the time, the batteries are degrading. So, you have to ensure whether all UPSs are running with their full backup time when you are doing a condition audit. This is the main final circuit wiring layout of a building. This is somewhat complex, but don't think about it more. Because here we are putting the locations of light fitting, fan, etc. And here this line shows how they are wired inside this area. So mainly you have to, you can read this kind of single line diagram. We will teach you during this condition audit. So some during workshop, we will teach you how to read this kind of final circuit wiring drawing. So here I am just giving you some introduction only. So don't worry about if you cannot understand it much more. At the final lighting circuit, there are another row is issued for the socket outlets also by indicating the locations of socket outlets and how they are fired in circuit. So these two types of drawing and the single line drawing will give you a complete idea about this electrical distribution system. Then when we are going for a building or a premises, next major important thing is the lightning protection. If we are talking about lightning protection system, there are two types. One is direct protection and other one is indirect protection. Direct protection means the protection from direct hitting lighting to a building. And indirect protection means if a lightning occurs in a transmission line or distribution line, indirectly it comes to a building or the premises via your power distribution line. So we have to protect the building or the premises from these two types of lightning or switching apart. So if you are going for a direct lighting protection, you have to install a system externally consists with these three systems. First one is air termination, and second one is down conductor system, and third one is air termination system. Air termination means, I think you all have seen a rod is installed at the top of the roof level in most of the buildings. That means the lightning is absorbed by that air termination system. That air termination system can be done with the mesh. That means you can use a mesh on rooftop or roof slab or the roof to absorb the lightning then or the air pinion. Or you can use these two as a combined system. Then down conductor means that absorb lightning you should securely pass to the ground. That means the lightning we have absorbed from the air termination system, it should be securely passed to the ground. For that, you are using down conductor. As down conductor, some buildings may have used the reinforcement inside the column at their construction stage, or you can use external conductor to pass that current to the ground. Then air termination means that passes current from the down conductors you have to safely earth to the ground. That system you are calling as earth termination system. It can be, there may be using foundation or raft or piles in the building, or there may be external earth. So when you are going to a building, you have to clearly note whether there is a lightning protection system installed in the building and what is the type, whether it is constructed with the building construction or it is installed after the construction of building, then what are the components, and all these things are installed correctly. So in this indirect protection means you have to stop the current coming into the building from transmission line or the distribution line. For that, you are using surge arresters. There are two types of arresters. One is class 1 and class 2. And also there are another type available at class 3, mostly used with very sensitive equipment. And today in market there are surge arresters available at class 1 plus 2 also. So that's a combination of class 1 and class 2. This is the pictorial view of a lightning protection system. The top part is we call that air termination. Then second part is we call that down conductor, and earthing part is we call that air termination. And indirect protection, these are called as the surge arrester. So this is how system is correctly earthed. You have to put the earth electrode, drive electrode into the earth, and you have to connect your sound conductor or the earth conductor to the earth electrode using a clamp, or there maybe you can use a exothermic valve as a connection to your earth electrode. So when you are going to the building, you have to clearly examine whether the system is correctly earthed using this proper method. I think I have covered the basics of electrical law, the electrical system. So shall we move on to electrical condition audit introduction? What is an electrical condition audit? A condition audit is a process of assessing the condition of equipment, wiring, grounding, and protection devices to identify any potential hazard in electrical distribution system. That means condition audit means simply we are checking the healthiness of your electrical system. That is the simple explanation. If you are using an electrical system, it should be healthy and safe. Otherwise, the user can be get electrified, and you can lose your life as well. Therefore, it is very important to run an electrical system in a very healthy and safe manner. That's why we are doing a condition audit to check whether our power electrical distributor system is in good condition. So these are the benefits of electrical condition audit. First one is accident prevention. As I told you earlier, if a system is unprotected, we may experience loss of human life, or some humans may get electrified because unprotected inflation. Then compliance assurance. That means you all know we are installing electrical systems to international or local standards. So if a system is not compliant with the standard, we cannot assure it is safe for use. Therefore, basically condition audit should verify whether the system is, or assure whether the system is compliant with the international and local regulations and standards. Then next benefit is improved system performance. That means if you are If your electrical system is installed, is not installed correctly, there may be power losses in your system. If you are not used correct cable size, that cable gets heated, then the power is lost due to the cable resistance, and power is lost as heat. So you have to check whether the correct cables are used in the system, and also correct equipment are used in the system. So therefore, if you are doing a condition audit and identify that kind of failures, and if you are rectifying that, your system performance can be improved. Then cost service. Cost service, if you are to detect early a fault early, you can save your equipment or some legal situation. That means if you are say if someone is get someone's equipment or someone get electric shock using your system, so he may go for say legal action, or his equipment may be damaged. So you have to compensate those damages. If your system is healthy, you have not required to compensate those kind of damage. So you have to save your cost if you are doing a condition audit in a system. Then enhance reputation. That means if you are having a healthy, safe electrical system in your premises or the building, everyone comes to the building is telling, wow, this is a nice installation, and there is nothing danger in this system. That means enhance reputation. Then let's see what are the main steps of doing a condition audit. First one is plan. If you are doing anything, not a condition audit, you are going for a designing or you are going to start a project, the first thing should be proper plan. So in the planning stage, you have to carefully plan what is the scope, what is the objective, and what are the resources required, and what is the team. That means you cannot do a condition audit with everyone. You have to have a team of qualified persons to carry out this assessment. So before starting this condition auditing, you have a proper plan. What is our scope and what are the resources we are required. That means when we are going to a condition auditing, you cannot just see and say whether this system is healthy. For that, you may require measuring instruments or some testing instruments. So you have to gather them prior to start a condition audit and a qualified team. Then the data collection. Data collection, that means you are going to premises and you are doing some visual inspection, and you are checking the available documents in the premises. That means whether there are actually drawings are available, or you can meet the technical person there and asking them what are the identified faults in the system. Like that, you have to get some idea about that system from a technically qualified person who are using that system. Then on-site inspection. The first thing is you have to inspect the system. As I mentioned in previous session of introduction to electrical system, you have to one by one, you have to inspect whether proper distribution boards are installed, whether the cable installation methods are okay. Like that, one by one, you have to visually inspect and record if there is any fault. Then the testing. There are several tests can be done during a condition audit. First one, you can take voltage and current measurement at several points, at MDB level, SDB level, and power distribution board levels and equipment level. The requirement is you have to have a required voltage level at every final point. That means if you are checking at the socket outlet, you must have the minimum voltage which is specified in the standard at that point. Otherwise, that system is not in good condition. If say the maximum allowed is if you are telling single phase, our system is 230 volts. So maximum voltage drop is for equipment level is 8%. If it is a light circuit, it should be 5%. More than that, we cannot say that system is in good condition, because the voltage is dropped and equipment can be damaged if you are using that system. So then insulation system is. That means you can test the circuit whether they are in good insulation resistance level. All these tests can be done during this condition audit, and you can experience. We are doing this test during the audit, and you can learn how to do these tests at in condition audit. So I am just telling now what are the tests and how to do it only, so you can experience it later. Then the circuit breaker protection and relay function is test. That means you can check whether the RPGs of the systems are working properly and please regulate are working properly. Like that, you can check. Then earth resistance test. That means the main earth or the lightning protection system earth are earth properly and they have meet the required resistance level. Then you can use thermal imaging camera to detect the heated point or power loss point. I think the fourth image shows you image of using a thermal imaging camera, which is used to see the condition of a system, and also this is mainly used in energy audit also, because condition audit and energy audits are almost same, but mostly energy audits are concerned about the power saving of the system, and condition audits focus on the healthiness and the safety of the power system, while energy audits are concerning on energy saving of the system. So the thermal imaging part we are used in both condition audit and also in energy audit. Then after collecting data and testing, we have to analyze the data, whether they are comply with safety standards or whether there are deviations. And after that, you have to do a compliance assessment after reviewing this data and details gathered during the audit. Then you have to do a risk evaluation based on the data collected and analyzed and give analysis. After those things are done, you have to prepare a report, and you have to propose the recommendations to rectify the defect of the system. So this one is the final outcome of a condition audit. That means after you passing the previous step, the final step is reporting and recommendation. So you have to provide comprehensive report on the faults which you have identified during your condition audit, and what are the recommendations you are proposing to mitigate those faults. So this is the basic steps of a condition audit. Then you can assessing the electrical hazard. That means you can identify whether there are risk of fire, or whether there is a possibility of short circuit in the system. That kind of electrical hazard, or whether there are exposed parts, exposed conductors in your system. Because if someone is touching that exposed conductor, he might get electric shock. So this kind of electrical hazard you have to assess, and also included in that report. Then you have to check whether these installations are compliant with safety standards. These are some common electrical safety issues which you can identify in a condition notice. First one is overloaded circuit. That means that circuit may be designed to handle 6 ampere current, but the user almost say 7 to 8 amperes from that circuit in some time. So this kind of overloaded circuit can be found during that condition notice. Then poor wiring practice. That means there are maybe exposed conductors, the protections are not provided at required positions, like that, poor wiring practices. Then lack of grounding. That means some earth can be disconnected, or some insulation there we cannot found earth wire, at least one earth wire. So that is lack of grounding. Then outdated equipment. That means most of the premises, some users are repairing their equipment, and also very outdated equipment are used. So it is not healthy for the electrical system as well as the users. Then inadequate maintenance. That means if you are running a system in healthy or safety manner, you have to maintain it regularly. You have to clean electrical panels regularly, and you have to check the termination, whether they are properly terminated or whether they are loose connections are available. Like that, you have to properly maintain the system. So most of the electrical systems are not in proper maintenance. So that's why most of the electrical hazards are increased in country like in Sri Lanka. Here are photographs. This is my experience during some site visits. You can see first image. The breaker is directly mounted on a wall without any enclosure. So if someone going and touch this breaker, definitely he will die, because there is no barrier or the obstacle in this termination point. There is no cover. Just directly mount this circuit breaker in a wall, and terminations are open to touch. The second picture. This is the backside of an electrical panel. Here you can see the top one, red color, yellow and blue are main conductors. Here you can see some small cables are taking out from this main bus bar. So there is no any circuit breaker for these circuits. This main bus bar may be has to handle 600 or 1000 ampere current. But you have connect directly a 10 millimeter or 16 millimeter small wire to this bus bar to take power out. If some short circuiting happen, definitely this will get fired. So this is a very dangerous installation. Mostly in your, if you are seeing this kind of site, you can see this kind of installation. Definitely in Sri Lanka, if you are visiting 10 sites, 6 sites are like this. Then here, this is the electrical panel room. They are using this electrical panel rooms as storerooms as well. With some liquid materials and some firing materials also installed in this kind of electrical room. If some sparks happen, entire building will get fired. This is another inside the electrical panel. See whether you can identify circuit here. I think no one can identify what is the circuit. There is a mesh inside the electrical distribution board. There is no proper routing cable, so no proper protection for the circuit breaker. So this is improper handling of cable. The cables are hanging from top to bottom. There is no support for the cable. So the cable can be get tension. It's like this of insulation. So when you are doing this kind of audit, you have to see and record and take photographs of this kind of mad insulation. It is a must during a condition audit. This fixed picture, you can see there is no access for this distribution board. Under this distribution board, the outdoor AV which has reset has placed. So in an emergency situation, no one can access this power distribution board and cannot switch off, or the maintenance cannot be done easily. The maintenance person should climb up to an outdoor AC unit to switch off the power distribution board or to the maintenance. The next picture shows there is a dust accumulated in the electrical panel. They have not cleaned it by many more years. I think this is not cleaned from 10 to 20 years. See the dust layer inside this electrical panel. And next picture also same, covered by dust, and under this bottom, the removed components are placed inside this electrical panel. That means the removed components, that means the malfunction components are kept inside this electrical panel without removing them from this panel. Then it is a mask inside the electrical panel. So like that, these kind of very unpleasant things are done by the user and also by the electrician. Mainly this kind of tapping and this kind of cable measures are mostly done by the electrician. And when they are repairing these things, they are putting these components inside the panel and let it there and go. And this kind of mask and gloves like that. These all photographs are my experience. These are nothing taken from the internet or any other place. These are also these photographs taken by me, and these are my experience during site visit. So when you are doing this condition audit, clearly you have to see this kind of installations are there, and you have to take photograph and record these and propose the method to rectify these kind of bad practices. So remember, electrical safety is not only a legal and regulatory requirement, but it also contributes to well-being and protection of individuals and assets. By investing in regular electrical safety audits, organizations can create a safer working environment and enhance system performance, safeguard their reputation. So keep in mind this paragraph, because this is the importance of doing the condition audit. Thank you very much for giving me this opportunity to discuss with you regarding condition audit. I think you can get more experience on this kind of audit during this project, CSR project, the Apeksha Hospital condition audit and this energy audit. You can learn more things and lot of things by participating in this kind of project. Thank you again for giving me this chance to connect to ISL and and individual section committee for viewing the evidence. Okay, that was good.
Thank you, Engineer Viranga Dasanayake. I am pretty sure, I'm sure that all of the participants who are present here had gained a lot of knowledge from this session, and I am very thankful for that. And as I mentioned to our participant at the beginning of our session, if you have any doubts or clarifications from our distinguished panel, you can raise your questions by using the chat option. And we already have gotten some questions. I think Engineer Viranga can answer those if I deliver those.
Sure, Kohila.
Okay. So we have gotten this question from one of our participants. What will be the possible issues in electrical distribution systems we'll be observing in the energy audit of Apeksha hospitals? So I think you can give a general answer for that. Yeah.
Yes, as I mentioned you earlier, I show you some photographs. So when you are going to Apeksha hospital, definitely you can find that kind of bad practices which was used in this hospital. Mostly in our installation, this kind of bad practices is done by electricians. So those are the major issues: improper cable handling and improper maintenance scheme and improper cable tapping, like that. You can find many more things like that in this kind of condition only. So you have to do what you have to do is you must take the photograph when you see this kind of malpractices.
Yeah, thank you, Engineer Viranga. And the second question we've gotten here. Okay, so they're asking, since there are highly sensitive equipments used in hospitals, what are the safety measures they have taken to protect them?
Maybe they have, I have told you there are several types of surgeries, class 1, class 2, and class 3. If you are using very sensitive or very equipment have to be protected carefully, there must be a class 3 surge protection also. And also there should be a voltage regulator and also some circuit breaker. When you are selecting circuit breaker, there are several types, that means type A, B, C, like that you can select. So very sensitive places, instead of type C, if you are using command, you may have used type B or type A circuit breaker to protect that kind of sensitive equipment. So when you are going there, you have to check whether that kind of special arrangements are taken to protect those sensitive equipment.
So we've gotten another question also. While conducting energy audit as engineers, what are the safety measures we need to follow? So I think they have mentioned about protective equipments in their questions, if I'm correct. So
yes,
I think
yes,
they are asking about those.
They are asking about their safety. That means our safety when we are doing audit, I think. So first one is during your visual inspection, you never touch anything, any electrical equipment or electrical panel. You should never touch those things. And when you are doing testing, you must interrupt the power. That means you have to switch off the main switch of the system or the main distribution board. You have to switch off the power, and you must verify whether the power is not available at the point you are testing the system. And also, when you are doing this testing, you have to use safety gloves. That means insulation gloves are available when you are touching these kind of electrical panels and when you are putting probe inside the electrical panel. So you must wear insulation gloves and you must wear safety shoes and safety helmet while doing this kind of audit. Definitely, when you are going for a site or for an inspection, not only for condition audit, you must use your protective equipment very well.
Yeah. Thank you, Engineer Verangadasanaga. Actually, there are some more questions that are directed to us. But since I've also been listening to the session, I believe if our undergraduates can listen to this session again, they will find the answers definitely because they were actually mentioned in your session. So we will be distributing our recording of this session with you guys, and you guys can refer to that recording at your own free time. And if there are further clarifications or you need more questions to raise, you can always contact any of the coordinators through our team. And again, thank you for this wonderful session, Engineer Verangadasanaika. So I believe we have come to the end of a fruitful time period where we both got the chance to share the knowledge as well as gain knowledge. So definitely at this time, I would like to invite another huge persona to deliver the vote of thanks. So if I am to mention, he's a chartered electrical engineer as well as an international professional engineer. And he is a former council member of IESL as well as a former YMS chairman, that he hold that title also, as well as he was the former vice president of IESL, Electronic and Telecommunication Engineering Sectional Committee. Engineer Navodana Kamkanamge, this is your time. So let me hand this session over to you to conduct the vote of thanks.
Thank you very much, Engineer Kaushila. Hope you can hear me well. Am I audible?
Yes, sir, you are audible.
Okay, thank you. Actually, today, this is very fruitful session. As IESL and both IESL and ECSL, I must say, we had two main objectives while conducting these kind of sessions. You know, now, not in Sri Lanka only, every country in the world, we are going behind some lacking of electricity. So energy efficiency becoming a must, and electrical engineers are the main responsible persons. Those days, maybe our electrical tariff is little much lower, maybe we are receiving subsidies. So we are not considering much on our efficiencies. But now it is not the case. Now we have to say every single electricity unit to survive. Maybe sometimes we cannot compete with our products with other countries because those countries are using more efficient and effective machines, but we don't have. And other hand, we have very major problem with the government organization, something like that, hospital and all. Now the electricity bill becoming a burden, it is very difficult to pay electricity bill. But still, there are so many things we can correct and rectify to efficient systems. So this collaboration with ECSL, IESL, and the Apeksha Hospital became that objective. Now, doing CSR project is very good thing. But say, if you need to do a CSR project, you can donate something to the hospital, or you can paint the wall of the hospital. But we are special in that case because we do energy audit or condition audit as electrical engineers, but not as normal people. So it is precious. We are doing that CSR with our knowledge and expertise. On the other hand, we had a passion to make more energy auditors, more energy electrical engineers who are concerning efficiency. So because of this one, whether we do or do not do any kind of CSR projects to the government organizations, still we are giving this awareness session to the future of the country. That is yours. This is a kind of, actually, this is kind of commercial practice. This is not an academic session. This is a commercial energy audit. We are doing this is free of charge because this is voluntary situation, but still this is commercial, because once we do that, definitely you can reduce the energy cost of the building. So this experience is not receiving from the academia. So that is why these kind of things are very important, and before passing out, you can hands-on experience those kind of commercial engineering practices, and you are doing those things under the mentorship of senior chartered engineers, international professional engineers, and sometimes you may receive very good exposure to the country and the big people. So this is very valuable for your career as well. So actually, this is a very good teamwork. Engineer Chamil Edirimuni was with us. He was the former chairman of this committee, and he initiated. I was the vice chair. So he and me initiated, but Engineer Varanga Dasanayaka, Dr. Sandun Konar were behind us. Actually, not only this one, we did a very comprehensive electrician guidebook as well, parallel to this one, because we engineers, we know everything, but still these things are doing by the electrician in the field, but they not follow all the standards. So that was the case. But little by little, one by one, we are achieving those drawbacks we had in Sri Lanka. And Engineer Sapumal Valisundara and Engineer Dilshan Vandara, Engineer Koshila, and Engineer Sandima, all together as a team, we deliver this thing to you. And we know this is becoming an asset for us, because you learn these commercial energy audits, and we can do good works to the country as CSR project and all as ECSL and IESL. I must thank our senior engineers who mentored us in both IESL and ECSL, both chair and all the council members and all senior engineers. We are paying our gratitude at that point. So with that note, I'm thinking this is, I am not taking much time, but still we are anticipating your active participation for these sessions and energy audits we are conducting, the practical sessions we are conducting. So thank you very much, you all. Thank you, Koshila, over to you.
Thank you. Thank you, Engineer Navadana. So I am sure all of the participants, our precious undergraduates today, understood the basics and they got a pretty good grasp about what we are planning to do and what they are going to learn throughout this online session, as well as I am sure that they have understand the gravity of this session, how much this is going to be an important part in their life and their career, as well as in their education. So let all of the good things come to an end. So as well as, so this fruitful session, it also has come to an end. As I mentioned earlier also, we will be providing the recordings of these sessions with you, as well as the presentation slides also. You can refer them at your own free time, and you are always welcome to ask questions, and if you need any further clarifications, you can reach out to any member of our coordinators team, and we will be there to help you guys, because this session is specially made and delivered to get the maximum contribution, maximum outcome of you precious undergraduates. So with that, let me wish you all a good wish you good luck for this beginning of this journey, and I would like to ask from all of you to stick with us throughout this whole session. It's going to be very useful for you and useful for everyone, and let's meet from another session, that means the second part of this online training sessions. Until that, good night and goodbye, and let's meet again through another fruitful session. Thank you.